All right, taping 7th hour here. Here's what should have happened, and I like what we went over this one first hour. I think I forgot to 4th hour, and then 7th hour had a great question, and I kind of misled him at first. Why I said 4 is different from 1 and 3. And by the way, this is I think the first worksheet on the I do have on our calendar, and on the calendar there are 3 separate worksheets. What's on page 2 of every worksheet? What's on page 2? The answers. So if you start copying them again, you're going to fail my test Friday. Did I just tell you there's a test Friday? Okay, and we knew about that I think already, but just to reiterate that. Anyway, back to this. This is different than 1 and 2 because 1 and 2 are not factorable. So you have to use a graphing calculator and analyze the zeros. We just found out 7th hour, number 1's a stinker. You had to really zoom in on one of the parts of the graph to find two of those x-intercepts there. It is not, someone said the word tangent or a bouncer. Did you guys say bounced or a double zero? Did someone say double zero? Someone said a double zero. Nice. It's not. It actually, you have to zoom in and see that there's 2 unique ones. Okay, now back to this. This one can be factorable by grouping, but you want to switch this around to make this a difference of 2 squares after you factor this. And you hopefully got to this point because factoring by grouping is a very specific when you have 4 terms and then you take out a GCF from the group terms, you end up with the exact same set of parentheses here. All right, so I'm going over one of those. Then I'm going to switch to the other worksheets. And I'm going to do a couple examples of those right on the worksheet. And we're going to use that as notes. All right, but anyway, difference of 2 squares, good FOILers, good whats? Factors. I know this is a difference of 2 squares because when I FOIL that, it ends up being the yellow. Now, some people are doing that, and you're going to get your quizzes tomorrow as a review aspect. Some of you guys are going in circles. You don't refoil this and then rewrite 49 minus x squared. You're checking. Does 7 minus x times 7 plus x equal 49 minus x squared? And it does, so that's the factorization of that. All right, so you're checking that you know this is a difference of 2 squares, therefore this unfoils to be 7 minus x, 7 plus x. And then you get these zeros. Now, x equals 7. X equals negative 7, x equals 1. Those are also x-intercepts for this particular graph in question. Now, I don't have time to play the polynomial game, but didn't we do the polynomial dance yesterday? And what I'm doing in class, this is a positive x cubed, right? I'm sorry, online, you don't get to see me doing a dance. And then this is how I get a negative x cubed, right? So that is how this picture would look through these intercepts. It would look exactly like this, and it would cross those x-intercepts, which tells me everything, just like I started class with going over number 27, what x inputs would work for this. And it's actually these that I have highlighted or scratched out here and here. It's because those create negative outputs, and negative numbers are less than 0. Do you see that? Okay, so therefore that's why that works graphically. So I never touched my graphing calculator. I did algebra to get the x-intercepts. I have knowledge that a negative x to the third should look like this graph. Put it both together and I'll be able to solve this very fast. And then put it in interval notation down at the bottom. All right, so that is the answer to number 4. Now, switch gears. And then what I'm probably going to run out of time with is I'm going to do number 8 probably after you leave. I'll be sitting in here talking to myself, all right, doing a little video of me doing this fractional question on that page. But hey, switch it over to this page. And I don't want to be rude, but to look at the top of that page, where did I have to grab these questions from? Algebra where? 1. All right, because this is an Algebra 1 concept. And then listen, how many science teachers need you to do these things, right? Take formulas and then rearrange them in terms of another variable, and they yell at the math department. What are you doing? Our students don't know how to do this, and I don't know, but you just try and keep trying to teach them. So here we go. I'm going to do actually number 2 and treat it as a note example. Okay, I did this with all the other periods. We are solving for A. So this is what I always do mentally, but then I'm actually going to do it for you physically with this highlighter. That is what I'm solving for. Now what this became is a question just like this. Just bear with me, all right? 3 equals A times 7, I'm just making up numbers, plus 4 times 2. I don't know. Because what I'm saying is the only variable that exists now is A. And I bet you everyone, I could do this red equation and ask, what would you do first? Well, you probably do 4 times 2, right? What's 4 times 2, everybody? And then what would you do next? What would you do next to solve for A? Subtract what? 8. And then after you subtract 8, what would you do next to get A by itself? Divide by 7. Why do students make a big deal out of this then? What did I just tell? Can you multiply R and D? No, they're variables. So what am I going to do next? Subtract that RD. And then subtract the RD. And this is even better, because you don't even have to do math. G can't be subtracted, or RD can't be subtracted from G, so you just write it. Those can't be combined, so you just write it. You write the operation, and that's all that can be done with that. And then what do you finally do to solve for A? What's the last thing? And guess what? You're done. Divide by C. Divide by C. I don't know why we make these hard or make them like seem like a challenge. You just have to have your skills for solving and just your undo operations, and then the ability not to be afraid of variables. All right, with all that being said, this one's a bugger. This one stinks. But I bet when I put numbers in place of those variables, we're going to be fine. So I have to solve for x. Oh no. Well, let me do it again, that weird thing that I did. I don't know, 8 plus 4x equals 2x. I'm just making up numbers. Because really what this means is x is the only variable in my mind. Okay? And that's how you really need to look at this. Now look at the red. What would you do first? Subtract 4x. You want to get the x's on the same side, right? Then after that, you'd have to do some sort of what? Division. Okay? Guess what? That's exactly what's going to happen with this. The very first thing you're going to do is subtract kx from both sides. And no, these can't. No, I didn't say this in the other hour. The x's don't cancel. That's not how that works. Yx and kx are not the same thing at all. They cannot be combined. They just need to be written right next to each other. So that's the kind of things that kind of mess us up. Like made up math, things that don't really work. They can't be combined. For two variables, or for two things to be a like term, they'd have to be the exact same variables. All right, that's all I have to say about that. Okay, well now we got a problem. So I'm just going to tell you what to do. Starts with an F. FA. You're going to factor. What are you going to factor out? An X. This is called a GCF factoring. As a Fattermact, I remember an Algebra 2 book that said, or no, an Algebra 1 book that described combining like terms through the glory and power of factoring. Wouldn't you agree that that's true off to the side? And then what's 5 minus 3? 2. That's why 5x minus 3x is 2x. So I've seen a pre-algebra algebra book show that, showing factoring as a way to explain combining like terms. Anywho, okay, I forgot the U. What's the last thing I'm going to do? Divide by a binomial, y minus k. And then I'll rewrite the answer at the end with it like cleaned up. Okay, and then this cancels, and then x equals u divided by the binomial y minus k. And that's it. There is no like splitting it up into two fractions. That's another illegal maneuver with fractions. Just get all these crazy things. All right, some of the other questions on that worksheet on that side are so easy, and then some are maybe as challenging as that one. So let's move on to the solving system. I'm going to be honest, I probably should have done this when we did lines, when we were doing equations of lines, because this is where this belongs. And again, remember what's happening. This is pre-calculus. We're trying to get all your algebra skills brushed up and then all these concepts that you've experienced before. And then see how good you are on the test Friday with those review concepts. You okay? Get stretch? Oof, long day, huh? All right, first things first, look at your worksheet and go ahead and eliminate these two words, or actually all of this. You do whatever you want. I don't want you to take a particular section and do it only by that way. This is CAT. We want to be efficient. We want to do the best possible way, the quickest way. I don't care what any other math teacher says. That's a mathematician. That's why we have symbols to cover not having to write big words for certain things. Blah, 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 blah. So this is why I like elimination, because the x's are lined up, the y's are lined up, the equal sign is lined up, and those numbers on the other side are lined up. So this is perfect for that elimination method. Before I continue, you got to be able to handle this stuff in Mr. Samuelis's class. You know that this is a picture of a line, and this is a picture of a line. I know, I just made these two up. What's the solution to this system? Where these two lines what? Intersect. And that's what you first did back in the Algebra 1 days. What's Algebra 1? I'm sorry, Math 1. This is Lockport. All right? So you graphed them to see where they intersected, and then you wrote the coordinate down. Then hopefully your teacher said, you know, there's better mathematical ways because graphing isn't the best way. There's one way called elimination. Who remembers elimination? Meaning, I'm going to multiply that top equation by a number, because whatever I do to one side, do the other. And I'm going to multiply that bottom equation by a number. And I'm going to try to get rid of the x's. Now I'm going to call you out 7th hour. First and 4th hour, someone was able to tell me what numbers those would be. 8 and what? 5. I heard someone whisper it here. And then anyone else that doesn't know what's going on, hopefully you watch and remember, and it spurs a little wrinkle in your brain that already exists because you've already done this. The reason we're going to do this is this becomes negative 40x plus 40y equals negative 40. And this becomes positive 40x minus 30y equals 10. Actually, this method is also called the linear combination method, because what you're going to do next is add these two equations together to turn them into one equation, which is a legal thing to do in order to try to solve this system. It's a weird little process. Do you remember doing this now? I hope so, because that's what all my role is up to this point, is just to reach in the deep recesses of your brain and pull out the math that you already know. Okay? Cross it off. Did you say freshman year? I have a picture of my daughter right here, just her hand. Do you know what she was doing today? Why don't you come over here just to prove this? Hurry up, run over here. Hurry up, we have no time for this. Okay? Look at this. You tell me what that homework is right there. What is that? She is solving absolute value what? Inequalities. And she's writing them. See that? Freshman in high school. Do you see that? I almost fainted at home when I said, what are you doing? That's what I'm doing with my cat students, meow, right now. Unbelievable. Anyway, I know this is not absolute value inequalities that I have right here, but y equals negative 3. Now, what do I do next now that I get y equals negative 3? I plug it in. Now, which one do you plug it in? It doesn't matter. 8x minus 6 times negative 3 equals 2. I plugged it into this equation. But now that I know what y is, I can plug it in and then solve for x. Because remember, it's a coordinate when you're done. So I hate to confuse you online there. I was just showing that what we were doing before this was the absolute value inequality solving. And now we moved on to solving systems of equations. Because of what I said, this is all review. And like I said, I'm trying to reach into deep parts of their brain and pull out the things that they already know. So you know what I should write at the end of this? I should write this as a coordinate, right? Sorry for writing that real small, but that's the answer. Now those graphs don't look like that. I just threw two lines there to show two lines cross, and where they cross is the solution. But really what it means is that that solution, -2 comma -3, makes both equations true. And that's why that's a solution for that. And sometimes you get special answers. This is why I said this. This one's ready for substitution. This is not a good one for elimination. If you were going to try elimination, you would have to subtract 4x and then go ahead and try, you got to get it where the x's and y's are lined up. This one is ready for that substitution method. Because if I have y equals y already isolated, then I could go to the other equation and wherever there is a y, replace it with what y equals. And that's what I'm going to do. So this next equation looks like -6x minus 2 times y. But y is replaced with what it is equal to, which from that previous equation, 4x minus 12. Got a lot of you on that quiz, which you will get tomorrow as a review, kind of don't make the same mistakes thing. You didn't distribute a negative. All right, and I'm showing that right there. That -2 needs to be plus -2, and then the -2 needs to be distributed. So little errors that people are making, their algebra skills need to be improved, or else this is going to be a long year. All right, and then this is -14x. You know what? I'm going to do two things at once. I'm also going to subtract 24 from both sides, because we're in CAT. And we should be able to do two things at once. I subtracted 24 from both sides and then add like terms at the same time. Hey, how many times does -14 go into -32 or 42? I'm sorry. 3 times. Zoom this in. So x equals 3. And then what I do is I plug it in. And I think it would be smart. Not supposed to call you smart. I don't know why. That was something that I was told back in the day. Don't call the students smart. Why? They're doing something good? Should give them a compliment. It'd be smart to plug it into the top one because it's fast, right? I mean, you don't even have to write that work. Come on. You can look at that. 3 times 4 is 12. 12 minus 12 is 0. There are some, I know I say show your work. And some people, I'll give you a little bit of leeways. You don't have to necessarily show that plug-in. But again, you should make this a coordinate. All right, and then like I said, and I'll put a note on this video. Hoy! 4th hour, I did start it, but I am going to go ahead and do that online if you wanted to watch how to do 8, which helps you how to do 7. It's a doozy. It does take a lot. Okay, so the 7th hour is packing up. All right, so I told them I'd start this, while they're packing up. Hey, I like fractions. Personally, I love them. But if I don't have to deal with them, I'm going to get rid of them. Hey, whatever you do to one side, do to the other. Okay, so what am I going to do to this side? I'm going to multiply by a 3 because that'll get rid of that fraction. That fraction. Do not forget that this has to be multiplied by 3. All right? So I'm going to write that off to the side here. This becomes -6y. There's still some cleaning up to do here. Minus 4x. Figure it out why I picked 3. It's so the 3's can cancel when I distribute that. Equals -14. Then, where are you going? Then, what do I multiply this one by? 8. Good, class. Because 8's the common denominator for this, and it'll get rid of all fractions. I don't know why I changed colors, but with -1/4 of 8 is -2. Oh, not a variable there. Plus 7x equals -8y. And now, I got rid of fractions, which it is easier to deal with. In purposes of solving this system. But now we got an issue. So what I'm going to do is get this ready to do through elimination. And I'll write the x's first, so negative 4x minus 6y. You staying for the show there? Equals negative 14. Do you have a question, or are you just staying for the show? Okay, add 8y, add 2, and then 7x I didn't move, so it's just 7x there. So I added 8y and added 2. We still have a problem, okay? So I like elimination, so I got it ready for elimination. All right, and I'm going to eliminate the x's again. So I'll multiply the top by 7 and the bottom by 4. So this is a doozy. It takes a while. I think it's smarter to get rid of the fractions because then it's more workable. Then you get negative 28x minus 42y equals, 70. It's never good at math. 70, 28, 98. Can you check that? Do you have your calculator? Okay, 28x plus 32y equals 8. I don't think I finished this one, so I don't remember. Okay, so 70 and 20, 7, 40, 20. 70 plus 28 is 98. And then you go ahead and add these. Chapow. This is a negative 10y. This is a negative 90. Divide by negative 10. And you get y equals 9. Now, for me to plug this into one of these might be a problem, because we have fractions. So as long as you have faith in your math, I could plug it into one of these other ones where I got rid of the fraction. So I'll take that green one. It could be any one of the two. And then we just have a little bit of solving to do after that. Negative 8y. All right, so again, this is still a weird one because everything's all cattywampus and all crazy. Negative 72. Whoops. And then add 2. And then that ends up being nice because 7x equals negative 70. X equals, divide by 7, negative 10. Okay, so a lot of work on that one. Lots of work. And then we want to make this a coordinate at the end. Negative 10, comma, 9. And that's all she wrote.